Hello, everybody on the NETIO webinar about integrations. Today, we will talk a bit about the integration model itself, about the integration with the AV drivers, which is basically not integration, it's something quite simple. How to use the JSON in devices, how to use MQTT, and in your integration, how it can be used in NETIO Cloud. So, for beginning, let me remind that the very useful tool you can use in all this stuff is NETIO Wiki. If you go to our web page, there is a support, by the way. If you can see the screen, let me welcome every single of you in Barcelona on the ISE. We are very happy that we will see after 2.5 years some people physically again. So come to the Barcelona. In Hall 5, we will be very happy to see you on the ISE. Okay, in the support link there is a link to NETIO Wiki. On this wiki you can find a lot of resources about the integration and all this stuff. So that's the first part I would like to highlight, that the wiki is prepared for the programmers. Generally, NETIO split the drivers and all the integrations between two resources. Something finished and let's say ready to use, you can find on NETIO page. So that's the reason we have a lot of application note. You can download the protocol definitions and things like that. All this stuff you can find and download, and that's quite easy here. That's one part. So it's, let's say, official part which is tested and so on and so on. Second part of all stuff you need for the drivers and things like that you can find on Wiki. Everything on the wiki is something like everything on the wiki is something like produced by community. So this is something where the community people produce for us, and we are printing it. Typical example: here are the drivers for Home Assistant. Yeah. Okay. Another thing is the drivers for Itzinga or some other system. Typically, it's a robot operating system where you can find how to integrate this NETIO. There are some plugins prepared and some driver from the community. So all this stuff you can find on the wiki, and don't ask us too much about the details because we don't know. It was produced by the people around the NETIO, other customers or other users. So that's the wiki. Okay. Second part where you can find some information is GitHub about NETIO products. It can be quite useful time to time because we are publishing there our own code. Very typical example, again, you can find on the wiki, and it's code called PyNETIO. So this is one of the things for the GitHub NETIO products, and this is the Python example how to use NETIO in your own projects, and so on and so on. So that's all you can find there. Fine. Also, on the wiki, you can find discover, means how to find the device on the LAN. This is important for the installation. If you need to install 1 or 2 devices, that's not the issue because you have our own tool. But if you would like to have this tool in your own software, this is the code which will help you to search for the device on the network. There are several standards. We are not following any common standard, no bonjour or something like that. So it's fully described here for it only. Okay. With this integration, you can let your customer to enter choose the IP address of the device from the list and not to write the IP address by number. Okay, about the NETIO Open API, we have several options. Okay, there is a web, but web is not API. It's API for human beings. We have a JSON. JSON is in default recommended protocol, and we fully recommend you to start with JSON. We have MQTT-flex, that's second recommended protocol. Then we have XML, and XML is something basically similar to JSON. It's just different structure of the code, but otherwise it's very similar. We have something we call URL API. We will show it today, but this is super simple and one way only. We have a Telnet, which is super old protocol. Since 2009, we still have some customers using it, and because of the reverse compatibility, we are using, but not recommended for any new projects. Modbus, something far similar, a bit too old protocol. By the way, it's my age protocol. It was fully described in 1977. SNMP version 1 and 2 and SNMP version 3. Yes, possible. And we have push protocols. That means a device are connecting periodically to the address, to define server, and pushing data there. It's useful for metering applications, but not for anything else. To be honest, we prefer MQTT than this one. Okay, above all this, we have NETIO Cloud, and even the cloud can be integrated to your system. We will talk about it in the end today. So today we will talk first about the JSON. JSON is fully recommended, and why? First, it's default protocol. So once you open the device from the box and the JSON is there in default pre-configured, be careful, don't forget to change default password. Second, JSON is something which is most stable inside buildings because it's HTTP. It's commonly using 80 port, and there's lowest amount of conflict is with JSON protocol. MQTT-flex is second option. This is very good for the cloud-oriented applications. So if you need to connect from somewhere behind the NAT to the portal or to something like that, then this protocol is really the right one. And in the end, I will talk about the NETIO cloud integration. So these three topics we will discuss today. Fine. First part, okay. AV drivers. We have a lot of AV drivers, and these can be easily used. It's something you don't have to in complicated configure do something like that. It's prepared and take it and working. Some others are coming soon. And yeah, this is not integration really. You just take a driver, go by the manual, and that's it. Anyway, if you will program or create in any AV driver, we would like to discuss what will be for free and what will be paid, because all the drivers we sponsored or we participate or something like that, we every time saying, okay, please with the drivers stay with simple write 0 to 1. For a free version, and if you want to have energy metering, if you want to have security features, if you have to have more features, these are the paid driver part. So the free of charge driver is typically for testing and simply switch on, switch off one output. That's typically free of charge driver. If you will write your own driver, please respect the default JSON and use the default configuration of the JSON. It will make it more easy for you and even for other people. Okay. Few technical info before we will keep going. Inside the building, so on the same LAN, we recommend to everybody JSON over HTTP. It's long-term and stable protocol based on HTTP. In longer point of view, we plan to update HTTPS to most of the products, and then it will be easy to cover in HTTPS. So everything you realize today by HTTP can be later on included to HTTPS. We prefer JSON than XML, but it's no big difference. And it's default enabled protocol. And there is only one JSON structure for all NETIO devices, so it's quite easy. If you are doing anything for the cloud-oriented thing, and you need to be behind the NAT, we recommend to use the MQTT-S and in flex definition, because there is SSL in default, so there is no troubles with security. The flex is extension of the standard MQTT, so you will be able to configure in simple text file all the data, like where to connect, how fast to send the data, to update about metering and things like that. And everything is prepared for that. There is option of periodical HTTP push, but there are troubles with that, and sooner or later you will need to control the output, and in that moment it's very silly way. Okay, so that's about the integration, and that's the reason why MQTT-flex and JSON over HTTP. In all protocols for all NETIO devices, even the output can be simply switched on or off. We have there 5 states. Okay, you can ask, okay, I have one lamp. The lamp can be switched on or it can be switched off. Why 5 states? It's 2. So simple answer like that. Okay, first 2 are simple, 0, 1. Okay, clear. But sometimes you can need to make a short off. means restart the lamp. It's not the same like to send a command to on and to send a command to off, or opposite, because then you will have to have connection and the time can be different. So in this one command, you can define for how long time does it means short. If I will show it in the graph, doesn't matter if here we will switch on or switch off, that's not important. We will send a short off. So this is the short time where we will be switched off and then on again. The opposite situation is short on. While short off is restart, short on can be used for the water pumps. So if they say I would like to switch off the water pump for 15 seconds to pump somewhere 2 liters. This is exactly this case where we will simply say, okay, now switch on for a certain time and then switch off. Fine. And last one, fifth, is simple toggle, invert the state. It's very useful if you would like to control the output by simple button, because once you push the button, switch on, second time you switch the button, switch off. So the toggle is very useful option too. So we have 5 states for each output we can use. First 2 are for read and write. These 1 are only for reading. No changes also for reading. Okay, so that's why in actions we will sometimes talk about 0 till 5. Fine. Let me remind that in the device there is a weak-based scheduler. Scheduler is switching the output by the time, by the defined scheme and things like that. And this scheduler is working in parallel with all your code. So you can in one time, the same output can be controlled also by scheduler, also by your code from your above system. So if you would like to use it only for your system from control 4 or from some other things, feel free to don't enable scheduler, switch off the scheduler. Something similar is here about the watchdog. We have new features called power consumption watchdog or ping watchdog. Nowadays, these 2 functions are available in all products since the last firmware, and based on that, there can be local conditions which are pinging to somewhere, and based on that, controlling the output. These local conditions and local condition and rule, these are also something which can control the outputs. So keep it disabled. In default, scheduler is disabled and watchdog is disabled. Fine. All these new blocks as a conditions and rules and things like that can be fully defined on the NETIO wiki. There is a lot of examples about that. Okay, and now let's start with JSON over HTTP. Fine. JSON is default enabled protocol. Let me show it. How does it looks like in practice? All you can find is in /JSON NETIO JSON file. So how does it looks like? If I will go to the product 8QS, which we have as online demo, on the online demo of this product, okay, no, you can see that there are some protocols available. JSON is in default enabled, and so you can see this is enabled for NETIO. Means if I will click here to this open JSON file, okay, I will have it here. So, okay, let's switch off this one. So this is the JSON. I'm just reading on this address. So /netio.json. I'm reading all this structure with all the parameters. For the output 1, I can see all the values like a phase, energy, power factor, load, and so on. For the others, I can see only the current state, 11001111, the default delay for short time, and the name of the output. Fine. You can see that even there is a block with inputs where you can see the state of the counter and the state of the input right now. So this is the JSON how you can read it. Basically, if you take part of this code and send it back to the device, you can control the output. Okay. There is unique identifier of the device in Mac, and there is also some special code called vendor ID. This is for special applications if you will need to modify your device through some sales channel or something like that. let's keep it for the future. Okay, so this is the structure for the HTTP as we have it. Default username and password for writing is NETIO. Any questions so far? Feel free to use your chat. I have it open in front of me and it's fully empty. Okay. As I said, there are some local conditions like the watchdog or ping, and these structures are in JSON available too. Fine. The MAC address as identification is every time on each device. So on the label on the box or on the label on the device, every time there is the number. And in the online demo, as I showed right now, you can see that there is MAC address double time, a serial number, and as MAC. Fine. There is full documentation for this JSON description. It's called in PDF. And there are basically two application nodes which can help you in beginning. It's AN20 and AN21. These are step-by-step guide how to test with the device, how to send some file to the device, and so on and so on. I have prepared a video. Hopefully it will work. This is the video about the old NETIO for all, but it's basically the same. So here you can see how we can control the output. This one output is number 1, and it was controlled. And here you can see that we are working with, in this case, XML, but it's the same. The XML, you go enable read write. So if you have it, and for these parameters, you can open this file. In this case, it's XML, but structure is exactly the same. And we will show now that this is the state of the output, number 1. And the magic, what I would like to show is here in this three parts, you can download either JSON, either XML code. That if you now save this file to your hard drive, this is the structure of the file. How does it look like? When you download it and save it to your file, you can take this file and upload to the device, and this is the simple way how to control it. So in this case, he downloaded the code. Now he choose the file which he downloaded before from the device. Okay, and in the web interface there is this HTTPS file upload, and I'm sending the file. On the background, you can see that this is the answer of the device. And look again to this output 1. Okay, let me come back in the video. Okay. So now he choose the file, and you can see the output 1 is switched off. He choose the file, send opened. Okay, and now when he clicked send file, and the output 1 was switched on. In the same moment, you got the response from the device. So this is the simple way how to demonstrate how the HTTP based communication works. XML and JSON is exactly the same. Fine. Wow. So that was the video. That was the video example. About these protocols, there are a few tips and tricks. You need to be careful about the IP address and port, username and password. Some devices can have a different amount of devices, but we ignore it. So it's no problem if you send to a small device 8 outputs, even it's 4 outputs device, we will just simply ignore the others. For toggle, you need to use action, not state. Okay, and this is some overview. If you would like to make the implementation of this product to your software, what to do. Follow the predefined username and password. Keep in your name there is to identify the device by the device name and also by the MAC address. Analyze the amount of outputs and show the outputs ID, because customers can rename the output. It will be I don't know, my chiller, and I don't know if the chiller is output 4 or output 40. And be prepared for HTTPS sooner or later. Fine. So that's about that. We prepared for this training simple checklist to keep in your mind if you are doing any integration with the NETIO PowerSockets. And that's it about the JSON integration. Any questions so far? Okay. MQTT-flex. MQTT-flex is typical integration for the cloud-oriented thing. So yes, generally MQTT is ideal protocol for the cloud-oriented thing, and the flex is our extension of this protocol. Flex is using standard MQTT, so 1883 or 8883. It's fully encrypted by SSL. Sometimes it's called MQTT-S, depends. And customer's flex configuration can be uploaded to the device's configuration file. I will come back to this issue in a minute. Okay, how does it work with MQTT? There is a, let's say, temperature sensor, and there is MQTT broker. In our application node 40, which is example for that, we are using HiveMQ system or HiveMQ software. So we will use it for demonstration here too. Because this is for free service, you can freely test. So there is MQTT broker from HiveMQ, and there is computer. So this symbol you can see now means that to the same one broker is in the same moment connected either temperature sensor, either laptop. So basically the broker is the central computer where both laptop and the sensor has open TCP socket in the same time. Fine. I am here just publishing the temperature, and because I subscribed to this, every single moment where temperature sensor sent new temperature value, this broker will send me info. Hey, there is a new temperature. The beauty of this system is that to the same topic can be subscribed more people or more devices. So in the same moment, I can share the same data about the temperature between my laptop and between my mobile device in the same time. And that's quite beauty. So this is the system of the MQTT. TCP socket is opened all the time. In a moment, in practical life, we will have a NETIO PDU somewhere. Let's say we will be connected through the LTE router or something like this. This TCP socket opened all the time means it will charge something like 50 megabytes per month only for keep connection. A different technology can be different. So let's say on edge it can be 80 megabytes, or on 5G it can be, I don't know, 40, depends on the size of the packet, but basically some amount data of like that. Fine. The broker have to be on public IP address, of course. And this information about how often I'm sending the data about the temperature, it can be defined somewhere. And this is kind of data structure. So what I want to say now is all this information means in which data structure, how often and where these data have to be defined somewhere. In MQTT, this is the issue because it's not fully standardized how it's set up and how it's defined. So in MQTT-flex, we have this information in the text file. What does it mean? MQTT-flex is basically kind of configuration. This is example that we have several devices, and all of them are sending data, for example, power metering, to the one broker. So in the same moment, they are all of them sending data to the broker. And the broker then send the data only to subscribed computer or some subscribed place. This is standard MQTT. It's nothing special about that. We are all the time talking only about MQTT communication. The flex is only configuration, where to send the data, how often, and so on and so on. So that's it. So flex is basically just configuration about the structure and so on and so on. Any questions? It will be more visible from next slide. So basically, standard MQTT is defined like this, and in flex you can see more data. So in flex, you can use several definable topics. So in one connection you can send more topics. You can have a user definable payload. So the structure is fully up to you. You can use kind of MQTT templates, and mainly you can define how often I will send the data about info, about, for example, if I'm metering and I will switch on TV, I can define it. Immediately I will send this data to the broker. Fine. Okay. So MQTT-flex, this config file is basically text file. This text file is defining what I'm subscribed for and what I'm publishing for. So I have two ways of communications. So this is how does it looks like. You can see that there is defined broker. That's basically the IP address where I'm sending data. Subscribe means, okay, I will accept the controlling of the output by the structure of the data. And for example, topic 1 and topic 2 with two different period or delta or event. So here I will send the data each 15 minutes, or if the value change more than half ampere, for example. And here I will send the data each 10 seconds, for example. Okay, so that's what does it mean, this flex. So this is the configuration. On the web interface, flex looks like the JSON structure, which is just text file loaded to the device. Nothing more complicated. So it's just the user editable structure. More details you can find in application note 40. There is also the video how to use it, and description of the structures are on the wiki. This is how does it looks like in Hive MQ broker. I recommend to test, because if you haven't more experiences with MQTT in beginning, it can be quite confusing. Fine. For the cloud strategy generally and about the clouds, I should define one thing. We have a device here, and this device is Open API, means all these devices can have a different protocols and different communication. Fine. In a moment, we are talking with a cloud. Okay, here can be your own cloud you create by yourself, and you have basically one device, one connection, or 9 devices, 9 connections. Of course, because if you have 9 devices, all of them are pushing data to this one cloud. Also, you can have your devices connected to NETIO Cloud. NETIO Cloud is our, let's say, 3 years free of charge cloud, which later on costs something like €5 per device per year. Okay, and what I would like to get your attention now is the fact that here you can communicate through MQTT-flex. Okay, but also you can get the data from the NETIO Cloud. So to your own project or to your own application, it's not only the option that 9 devices will be connected to your broker, but also that all these devices will be connected to your user account on the NETIO Cloud, and you will get data only from the NETIO Cloud. It's much easier, and from long-term projects it can be stable, because the NETIO Cloud compatibility we can guarantee from long-term point of view. Okay, what does it mean? In the web interface, we have controlling the device. Here is the log file in the web interface of the unit, and this is some details about application note 40. And here we are about the NETIO Cloud, and basically all I said now too fast is here in more details. So basically, you can have a NETIO Cloud, and communicate from the NETIO Cloud to your own system. So basically, you don't have to connect 10 devices by 10 connections to your own cloud. You can connect to your own cloud only the MQTT interface of the NETIO Cloud, which means one connection, one configuration only. How does it look like? This communication is also MQTT, and every time when you go to NETIO Cloud and click to little pen, you can see this is the MQTT topics. So this is the structure of this one output, and here you can see all the data how to connect to your own cloud. We would recommend to everybody use our cloud, because it's from bigger project, it's much faster. Okay, it was too much in details and too much deep. but I'm more or less in time. Do you have any questions? No one at all? Okay. If you don't have any questions, let me invite you again to Barcelona in middle of May. And let me thank you for being with us here on this webinar. And have a good day. Maybe see you on next webinar about some other topics. And yeah, I have a question from Gary. Yeah, if you will use the NETIO Cloud, what's the pricing? This is a good question, Gary. Thank you very much for this question. Yes, every single request to NETIO Cloud costs something. Basically, the same price you are paying in credit device to the cloud, you are paying if you are connecting to your own system. So in the end of the day, we can say that to connect the whole NETIO Cloud account to your own software will basically a little bit increase the fees you are paying per year, but it's not no sky high price. So basically, it depends on the limits how it's set up, and it costs a little bit more, but nothing sky high for the MQTT. It's charged from the credit, and we keep it for a quite cost-effective price if you are talking about the controlling the outputs. In a moment, you will start to discuss about analyze the power consumption. The price will be higher because you need to get much more data and the traffic is much higher. But this is for more discussion in this topic. Okay, if there are no more questions, you are welcome, Gary. Okay, if there are no more questions, then let me thank you everybody for being with us on this NETIO webinar. See you in Barcelona if you can, and see you later again on some other NETIO webinar. Bye from Prague.